Today, as we talk about circumference and area, we're going to be looking at different forms of pi. Pi is going to be the one thing, along with radius, that connects these two ideas of a distance around a circle and the area of a circle. No other shapes, no other polygons use pi to find any form of their perimeter or their area within. Only circles, because of the unique ratio of the distance around the circle compared to the distance across the circle through the center. So as we begin, what are some common forms of pi and when would they be used? One of the most common forms of pi we have is our 3.14, which is what most people are used to. So does it have any distinction between another form? Say if we were to go out more decimal places? No, we could go out more decimal places, but generally most books, most of a student's need is to round to the nearest hundredth. So we round it to 3.14. So this is the most commonly used form of pi as an approximation. Another one, if we're just trying to get a quick glance, maybe we're doing something out in the field, you're working with science, you're working with measurement for whatever reason, you just need to have a rough estimate. You're not looking for a huge accuracy, just a big idea of how much space is being taken up. Some people might use just 3 even as an approximate of pi, because it's almost 3 diameters around the circumference of a circle. So it's pretty close, but not exact. It's getting a little bit farther away from that exact point. Some people also use fractions. The common one is 22/7. If we were to change this to a mixed number, we'd have 3 and 1/7, which comes out more or less to 3.14 something something something. So it's pretty accurate. This one we generally use if we're dealing with fractions. So if we're given a radius that is a fraction, or if we're given an area or a circumference and we're trying to solve for the radius, this would be a good use of that. Another reason we might use 22/7 is if we have some form of a multiple of 7. So our radius is 7, 14, 21. Something that is a multiple of 7 would be good to use with 22/7 because they would cancel each other out. You'd be able to reduce and cross factor and so on. And then the most accurate is just the symbol, and we've been using this one in class. This is just the symbol pi that represents every single decimal place. You could even write it out something like 3.1415 ... It's going to include every single value, even though we are not ever going to be able to come to the end. So in this context, we want to know what pi has been used to be able to figure out what our radius was. The different contexts are going to determine whether or not someone used a 3 or a 3.14, 22/7, or pi itself as a symbol. When we're given the area or when we're given the circumference and know what pi version or to what accuracy the pi was used at, then we can find out with great precision what our radius or our diameter is of that particular circle. And that's what we're going to focus on today. Using the circle above, we're going to be given the area of this particular circle. In fact, I've given you the radius just so that you can see more clearly how this process might work. I want to find the radius, or in this case I'm going to actually find the diameter. I'm going to be asking for what is the diameter of this particular circle, and I could clearly find it's 12 feet because the radius is 6 feet. You double that. We talked about this in class. However, let's imagine that we don't know what the radius is already. So I'm going to cross this out. Let's imagine we don't. So we have this x. We have this unknown value. How could we find this particular measurement to be able to then determine the actual diameter? If I know the area, which is given, and I know the pi used in this particular example, and I'm going to let you know that I used the most common. I used the 3.14 as my pi, my approximation for pi. Then I can determine what the radius actually is by working backwards. So I start with the equation, the formula that tells me area. So if you remember, we have that base, pi times r, times the height, radius, or together pi times r squared, And I can work backwards from here. So I know what the area is. It's already been given to me. So 113 and 4/10. I know what pi is. I'm telling you that it's the 3.1 approximation, 3.14 actually, 3.14 approximation times the sum r squared. If I know this, then I can take what I have on this side, isolate my r squared here, and move this over. If I bring it over to the other side, I have to use its inverse operation, which means to divide. So I'm going to actually divide both sides by 3.14. These are going to cancel, and then I have this 113 and 4/100 divided by 3 and 14/100. If you do the math, we actually get 36 equals r squared. Now to figure out what 1r is, we have to remember that this is not r times 2, this is r times r. So something times itself. If we ask ourselves, okay, well what's times itself can equal 36? Another way of looking at this is, what's the square root of 36? Because this is being squared, so to work backwards we take the root of that. So it's like saying the square root of 36. And we know that it's going to be positive because it's a distance, so it must equal 6. And we know that already because it was drawn into the diagram. So again, it's not just 6, it's a distance, so 6 feet. And then this radius can be used later to find the total distance of the diameter, because we know that it is twice the radius. So 2r equals our diameter, so 2 times 6 would give us our diameter, or 12 feet. There we go. Knowing the pi of the approximation, or knowing whether we are going to use it in its accuracy as a symbol, and knowing either the circumference or the area, we can then determine and work backwards to find any other aspect, concept, distance, measurement that is dealing with our circles. Make sure you write down any questions you have and bring them to class tomorrow.